Hey everybody, in this video we are going to look at solving inequalities using multiplication and division. And we're only going to do one graph of the inequality because we looked at that last time. I think we should be able to do that even without it in this video. So, first example, we have x divided by 5 is less than or equal to -3. So again, we want to isolate our variable using inverse operation, so we would multiply by 5 on both sides. That's going to leave us with x is less than or equal to -15. So we can go ahead and graph that. Less than or equal to means we're going to have a closed circle at -15 and our arrow going to the left. And I should probably use a different color here so we can see it more clearly. All right. Looking at our next one, n divided by 3 is less than 1. So again, we want to isolate our variable. So we can multiply both sides by 3. That would leave us with n is less than 1 times 3, which is 3. And again, I'm not going to do the graphs for all of these, but we would do an open circle at 3 with our arrow going to the left. Okay, in this next example, we have -0.5 is less than or equal to m divided by 10. So we can multiply both sides by 10 here to isolate m. 10 times -0.5 would be -5. So we have -5 is less than or equal to m. And again, remember, if we were to graph this, we can rewrite that as m is greater than or equal to -5, right? We want to remember which side of our inequality the variable is on when we're graphing. In this next one, we've got 4b is greater than or equal to 2. So we want to isolate b by dividing both sides by 4. That leaves us with b is greater than or equal to 2/4, which simplifies to 1/2. Again, if we were graphing this, we'd have a closed circle at 1/2 with our arrow going to the right. And this next one, we have 12k is less than or equal to -24. So we isolate k by dividing by 12. That gives us k is less than or equal to -2. All right, now an important note. When we multiply or divide both sides of an equation, or rather, I should say, both sides of an inequality by a negative value, then we need to reverse the direction of the inequality. Let me show you what I mean. Let's look at these two examples. 3 is greater than 2. This is something that we know to be true. Now, if we were to multiply both sides of that inequality by -1, that would give us -3. And if we didn't change anything, it would say -3 is greater than -2, which is not true, right? So when we multiply by a negative value or divide by a negative value, we need to reverse the direction of the inequality. So you can see here, I've written, when we multiplied by -1, we changed that greater than sign to a less than sign. So -3 is less than -2. Another example here, you have 5 is greater than -3. So if we divide both sides by -1, again, that would give us -5 is less than 3. So remember, whenever you divide or multiply both sides of an inequality by a negative value, we need to reverse the direction of that inequality sign. In these examples just now, I've shown you with whole numbers just because that's easy for us to see and understand why it's changing. Obviously, we still need to do that even when there are variables involved. So for example, x divided by -3 is greater than -4. So in order to isolate x here, we would need to multiply both sides by -3. So remember, whenever we multiply by a negative value, we need to change or reverse the direction of the inequality. That then leaves us with x is less than -4 times -3, +12. Finally, our last example for this one. -12 is greater than or equal to -6y. So again, to isolate y, we would want to divide by -6. Negative 12 divided by negative 6 is positive 2. Again, we divided by a negative number, so we need to reverse the direction of our sign. And negative 6y divided by negative 6 is simply y.